The minibus is one of the most popular modes of public transportation available in Hong Kong. However, there is still room for improvement on the design of minibus. For example, most passengers seldom fasten their seatbelts. Foreign travelers or even some locals may find it difficult to get off. And the ventilation is usually poor as the windows can never be opened. There are still some more problems we found. In order to solve these problems, we try to take advantage of the new technologies to improve the design of the minibus.
Based on the concept of biomimicry, we propose to redesign the windows by mimicking the gills of sharks responding to wind flow. The gills will flex to allow fresh air in, so passengers will not have to open the windows manually for better ventilation. Also, to improve the safety, the gills are slightly overlapped so as to prevent children from putting parts of their body outside the windows. Inspired by super hydrophobic qualities of the lotus leaf surface, our second proposal is to apply a lotus effect self-cleaning paint or exterior coating to the minibus. This self-cleaning ability will help to reduce the amount of wastewater used for cleaning.
The form and movement design changes that we propose consist of revised seats with an adjustable orientation and direction to improve the experience for passengers. Automatic seatbelt fastening has also been included in order to ensure greater safety for passengers, as currently passengers will often simply not use the seatbelts on the minibus. Integrating a mobile step for easier access to the bus for the elderly or physically impaired is another proposal, with the step itself incorporating piezoelectric, deformation-actuated panels to contribute to the minibus's renewable energy sources. Lastly, we intend to redesign the doorway to improve the efficiency of passenger changeover and therefore the efficiency of the minibus's operations in the long run, achieved through a widened doorway, thinner doors with a smaller footprint, and a two-way simultaneous entry and exit system.
Firstly, regarding the use of technology and smart materials, an app will be developed that contains the routes of the green minibuses, allowing commuters to get their bearings. This app will also connect to a vibrating alarm in the seat that can alert passengers when they must alight, allowing passengers to sleep in their seats if they desire. Another problem with a minibus is that it can be difficult to gauge the available space on the bus. In order to solve this, piezoelectric material will be used in the seats, which connects to an LED display showing which seats are occupied on the bus, allowing passengers to accurately gauge how many seats are free and whether they can board the bus or not. Another implementation will be the use of photochromic materials in the windows, which will automatically darken if the surroundings are too bright. This will be used to ensure the comfort of the passenger as they are boarding the bus. In addition to this, the windows will be double glazed, such that the interior of the minibus can be properly insulated, so that it doesn't get too hot in the summer and also does not lose too much heat in the winter.
Sustainability. The hybrid energy system uses both LPG and clean energy. The vegan panels are installed as the deck floor to generate electricity from the kinetic energy of passengers' footsteps. LPG will be used when there is not enough kinetic energy. This system reduces the demand for fossil fuel and reduces carbon emission. The rainwater reuse system includes a rainwater harvesting system, a purification device, and a water supply system. Due to the lotus effect, rainwater can stream down smoothly into slits and gutters. After purification, it will be stored in storage tank for later use or delivered to where it is needed.
To conclude, we have made quite a number of improvements on the design of the minibus. We hope our design can optimize the user interaction to be an experience most tailored to the user needs.